So let me get that. Okay, how do we get to the other thing actually?
Yes.
Okay, perfect. Yeah. Okay. Great. Yeah, thank you for showing up, and also thank you for the invite. It's a great pleasure to be here. I want to talk about essentially data sovereignty and how that can actually be realized in order to have like a truly decentralized internet again. Let me start with getting the next slide ready. None of them is working.
Yep.
Okay, thank you. Okay, let me motivate a bit with contrasting ownership in the physical versus the digital world. So, for example, if you buy a book, right, you have a very clear sense of ownership. You can read it, you can borrow it to somebody, you can sell it, right? It's yours. Also, like say, if you have a photo or some sort of maybe communication that is yours, you can decide who sees it. It's owned by you. Only you have access, and you can decide what to do with it. If you go to like the digital world, typically also like involving cloud services, then like for example, like the book is not, you don't own the book anymore, but rather you own a license to read a book, and you are subject to the terms of the platform provider. For example, you might not be able to sell it, you might not be able to borrow it, and you might also not be able to read it in a different format. Same with photos or other kind of communications. You storing it on somebody else's infrastructure according to their terms, and you could, for example, lose access, and they could also maybe use that material for other stuff. For example, they could maybe use your photos for training purposes of AI models, or face recognition, etc. So it's really not like yours anymore, but rather you're depending on another sort of party. And of course, that can be problematic. So let me give you two examples, and there are many more. You probably have heard about these already. So think about Reddit. We all know, right? It's a platform where you can have discussions. People interact. There are different subreddits with lots of different topics, and there are people actually contributing their content there, and they're also volunteering moderators that curate content. And now in 2023, Reddit decided actually to cut down the APIs to the platform that were previously open and used, for example, by moderators to do their job. Also, they were used by third-party applications for access and access to the platform. And Reddit closed it. Why? Because they wanted to monetize and use like the data to sell it to LLM companies. And that was done, a big backlash, because then people realized, like all the content that they had provided all of a sudden was behind like a fence, and there was not freely accessible anymore. And then some Reddits actually went dark, so there was a big, big revolt resulting by that. And I think that's a very good example of where people actually generated, their time and their content, but now they realize the dependency on a central platform. Similar, like in the Reddit case, like a father took pictures of his son for medical purposes that was then wrongly classified by Google platform as sex abuse pictures, and then this person actually lost all access to like contacts, email, photos, everything. Whole digital life was gone, and even after court cases, then Google refused to give back that access, although actually this was really wrongly classified. And there are many more of such examples. And yeah, so that clearly shows, like, we are in a stage where we probably should care a bit more about our own data and how we actually control it. And interestingly, if you look at the history, and you probably have seen that already as well, is that, like, if you look at the history of the internet, it started actually in a very decentralized fashion. Like, it was Web 1.0, static pages, read-only content web pages essentially, limited user interaction, but it was an open protocol, and it was actually running on a decentralized infrastructure. Then Web 2 came along with interactive web apps, social media, user-generated content at scale, but also now, on the flip side, centralized platforms with a few big companies really controlling the access. And now I think Web 3, right, I would define it as really like the best of these two worlds. You would sort of keep the decentralized nature of Web 1, but the interactivity of Web 0, and therefore users would again own back their data, their identity, and have sort of privacy and sovereignty restored. Now let's think a bit about how that could be realized. So here's actually my wish list, which is a bit cut off, but it's okay. I mean, I summarized it in 3 points. So the first one, if you want to have a decentralized internet, of course, you need decentralization, but I think I want to be a bit more specific here. So I think it's not just enough, right, to have, say, one component decentralized, but rather I think you have to go through the whole stack, like the network, like the control of the platform, the applications themselves, and also the data should also be like fully decentralized. Then scalability, I think, is important. I mean, if you really want to use it day to day, it has to be fast. You need to be able to add additional power, right, if usage is growing, and it also has to be at fair and low cost. Otherwise, people won't use it. And I think another point is interoperability. So even if you have a great service, typically, you won't cover everything. You have to be able to interact with the outside world, and that could be other blockchains, but also maybe other Web 2 services. Yeah, and now I wanted to, in the next few minutes, I want to show you, like, how we can sort of create a protocol that really ticks the boxes on this wish list here. Yeah, so I'm working for the Definity Foundation, which is a major contributor to the Internet Computer Protocol. And the way, like, now I think I'm going to explain a few design decisions of that protocol, really linking back always to the wish list that I just showed you. So the first point is that this protocol actually runs on a set of standardized high-performance nodes. So like each of these nodes costs roughly $20,000, maybe compared to, say, $1,000 for Ethereum node, so much more expensive. And they're also standardized, so they're very similar. And why is that? Because of scalability reasons. Like if you want to have decentralized computation and you want to have similar compute capacity, otherwise, like, you might have to wait for the slowest always. So that choice is respect to scalability. And the next point actually is like these nodes are not allowed to run in the cloud because then you would dependent on a cloud provider again. But they have to be physical nodes that are running in data centers across the world. Right now we have 1,400 nodes in more than 30 countries all over the globe. Yeah, that really gives you like this additional degree of decentralization really on the hardware level. Now, when you think about how to connect these nodes, there's a trade-off, right? Like if you want to have maximum redundancy, maximum security, you probably want that all calculations go through all nodes. But on the other hand, of course, that makes it expensive as well, if everything has to go done by everybody. So like the decision here was now for, again, for like scalability reasons, that like these nodes are actually grouped into subgroups, so we call them subnets. Yeah, pictured here as these little groups. And that way you can it's like a scalable protocol because, like, for example, if you need additional computing power, you can just add a new subnet. So it's like a horizontal scaling that would realize. And you can also fine-tune like these groups according to the security need of the applications running on them. For example, if you say have computations which were highly security sensitive, you might want to have a subnet that has many nodes. And if it's more like a simpler application, which is not very critical, but therefore could be like run on a cheaper subnet, you can also choose that. So like there's flexibility in the way you build up these groups. Yeah, and then on top of these subnets are smart contracts. In our language, it's like we call them canisters, so depicted by these little cylinders. They contain state and code, and they can interact with each other, and they can also crucially talk to other smart contracts on other subnets. And you will see also later They can also talk to the outside world, to Web2 services, or to other chains. And you as a user, you can also directly interact with these smart contracts. Like you can, via like your phone, and we'll see that later, you can directly call and, for example, have an interface running on such a smart contract. Okay, cool. So we talked a bit about now the scalability aspect. I want to come back to the governance. So here, a special feature, really, in order to have like this fully decentralized control, is we have an on-chain DAO that controls really the whole protocol. The way it works, we like people that have like the token underpinning the internet computer, which is ICP, can stake it, and then they can participate in governance. And the governance runs in a smart contract on the blockchain. And I think what's quite special is that really everything is happening on-chain here. So like if you submit a proposal, you do that on-chain. The voting happens on-chain. Also, like when the tally is complete, the result is ready, the execution is also on-chain. So like there's no one in the middle that needs to execute the proposal. And furthermore, you can actually affect different layers of the protocol. For example, you can vote on adding a new subnet, deciding on the size of a subnet, so things on the hardware level. You can decide on things which are more on the protocol connecting the nodes, for example, the consensus. You can update the consensus if you want to via proposal, and you can also change the environment in which the execution environment in which the canisters, the smart contracts run. And you can, of course, also change parameters like, for example, affecting tokenomics. Yeah, and I think that's, I would say, relatively unique. I think very few chains really have like this really full stack execution of proposals. I think it's quite important because otherwise you were always relying on somebody that will take a decision and implement it, or maybe or not, right? So I think that's really crucial here. Now the cool thing is, like the same concept for controlling the network can also be used. Actually, no, like give me one more example before I go to the next one. Yeah, here's one example of how that works. So if you think about network level, like the, for example, you can decide on how like these subnets are constructed. So you can see depicted here, you can demand that you have a high degree of diversification on the country level, so that, for example, like the nodes in the subnet are coming from different countries. That gives you a higher degree of decentralization. Also, the node providers, the people that operate these machines, are publicly known. So you can also make sure that the same node provider doesn't appear twice in any subnet, again, in order to have a high degree of decentralization. Yeah, now what I wanted to say before is now we can extend that actually to the application ownership. Like a classical setup maybe would look like this, right? You have a developer or maybe a developer team, and that team writes a cool application depicted by like this smart contract symbol here. And then you have end users that use it. I mean, for example, let's say a social media application running on chain. That's of course not decentralized because like the developers here can decide at any time, for example, to switch it off, or maybe to make you pay for something. So it's like would be not decentralized at all. But like the same concept of the on-chain DAO can be actually used also to launch DAOs controlling applications. And the way that looks is you launch a new DAO, and there's like an existing framework that we have for that, where you sort of add a new smart contract, which is a governance smart contract just for the application. It controls it. And when you launch it, you kind of distribute tokens to users, to the developer team, maybe to investors as well. And they together then will like have the right to vote on and control this the application. And then you can really, yeah, so the future of the application then would be up to the community, including the end users. And that's pretty cool, I think. And the like this framework is already live, I would say, for 2.5 years now, and more than 40 such DAOs controlling real-world applications have been launched and collected in between them more than $80 million, which is now sort of sitting in the treasuries of these DAOs. And then now like the community can also decide on how to spend that money, for example, for paying for adding additional features to the applications. Okay, cool. So now I want to come back now to the last point on the bucket list, interoperability. So another cool feature of the protocol is that if you have a smart contract that lives on the internet computer, it can actually natively own private keys. And these private keys can be used to sign transactions. For example, you can natively own Bitcoin or Ethereum in a smart contract on the internet computer. That makes it quite powerful, of course, because, like, for example, you can build a DeFi application that allows you very fast and very cheap trading for Bitcoin, say, and there's no bridge in between that sort of on which you depend, but rather you have full interoperability and still decentralization. And the way that actually works, if you look under the hood, of course, it would be like, not good if sort of like the secret key would be sitting in one of the underlying nodes, because then that particular node could steal the money, right, linked to that key. So what's done here is using threshold crypto. So each of the nodes contains only a part of the secret, and only if sufficiently many of these nodes agree, they can jointly sign a message and, for example, trigger a transfer on the Bitcoin network. And it's not just limited to transactions. I mean, it could be any kind of message, like, it can trigger any kind of message, say, also on Ethereum, like, if, for example, if you interact with a smart contract on Ethereum. Yes, and I think in a similar sense, like you can also interact with other Web2 services. A similar story here, like these smart contracts can directly connect to the outer world, and like the result would be processed via the nodes and going through consensus. And that way, for example, like you can build an application that collects maybe weather data, temperature or so, from the outside world, and then integrates that into your smart contract. Okay, cool. So that's the last slide I have on capabilities. I think this thing here, I could keep it to the end if there's still time. Yeah, so actually, the one thing I want to mention is a very cool new product which we have is called Caffeine. It's launching mid of October. And what it does actually is it allows you to talk to an LLM to do vibe coding, essentially, to develop an application. But the key difference here compared to other similar applications is that you actually can deploy then directly this application on-chain, in this case on the internet computer. Yeah, it's like the development and like the deployment and also sort of error fixing happens all with an AI support. And that means like people that are not technical, that for example don't know how to program, can use Caffeine really to deploy their own applications. If you want to try it out, I have some, I mean, it's not yet open for everybody, but I have some sort of invite codes. So please come to me after the talk if you want to try and play with it. Yes, and here now on the conclusion for the talk. So I think we had like this wish list, right, for a decentralized internet, having a decentralization on different layers of the network, scalability, fast, scalable, and low cost, and interoperability. And I gave you sort of a sense on how we can realize these things in a decentralized infrastructure. And therefore, I mean, conclusion is, we have all the tools at our fingertips now, and so it's time again to own the internet for ourselves. Thank you for your attention.